This conference will now be recorded.
So let's start with virtual private clouds, VPC. So let's understand first what is an VPC. Anyone? Any idea what is VPC? I ask you what is VPC, not to elaborate VPC. NAT gateways. Any networking guys? No? So let's understand first what is VPC. So don't say that in interviews. What is VPC, virtual private cloud? What is RDS, relational databases? Everyone knows it. So the meaning, so that is the purpose of the questions are asked. Okay. Well, so so this is our AWS. So AWS cloud. So this cloud we call it a public cloud. So what is public cloud? Anyone can log into AWS and they can create their resources, right? Well, now, so this is what is a public cloud. Anyone can use their account, they can create their accounts, they can create their resources. So that is what is public cloud means. Now, so for example, I'm a user, and then I'm creating some instances on AWS public cloud. So that is my instance. Now, but the question is this instance is secured? So I don't feel it's secured. Why? Because I'm creating my instances or my resources on AWS public cloud. I don't feel it's secure. Even though you have private keys, so even though you set up some security groups, still I don't feel it's secure. I want to provide more securities. I want to create a kind of a layer. So that is what we call a VPC layer, or we call it a virtual private cloud. So that means on AWS public cloud, I want to create my own cloud. So which is what we call our own private cloud. We call it virtual private cloud. Okay. So that we can provide more securities to the resources. Now, once I create this virtual private cloud, VPC, and then at VPC level, I can provide securities. That means at network level, I can provide securities. So securities, and same time I can provide securities at instance level. So now we have two layers of securities. One is that network layer, which is private cloud security layer, and then also we have instance level security. Right. So what we call these instance level securities? What do we call them? Or how to set up them? Security groups. Now, if you want to set up network level security or virtual private cloud level security, we call them NACL, Network Access Control List. So any user, for example, from outside, those whoever wants to access the instance, for example, this is an EC2 instance. I want to do SSH onto this EC2 instance. Then this user should be allowed at two layers. One is at NACL level, other one is at security group level. Okay. So this is our networks. This way we can provide more securities to the resources within that network. Okay. So that's one reason. Or else, let's talk in terms of a project level. So if you talk in terms of project level, how do you provide securities then? Now, so this is AWS Cloud again. So in my project, we have multiple teams. So we have developers, we have testers, different environments, development environments, test environments. Also, you have pre-production, production. So we have a number of environments. There. So how do you create those environments? Now, so there I would go with creating my own networks. So we call them environments. So I'm going to create a different environments. So this is for test environment, and this is my test VPC. For testers, I'm creating their own VPC so that this environment or resources or instances in this environment can be accessed only by the testers. Or else I have so particular development environment. So I'm going to create so dev environment, and this is dev VPC you said, and there we have VPCs, there we have instances. So I will be creating instances only in this dev VPC. These servers or these instances can be accessed only by the development teams. So this is how you create environments at so project level or real-time level. Okay. So this is a second purpose. So why we need VPCs? So we have seen basically VPCs are for to provide more security to the resources. That's first reason. Second reason is whenever you want to create environments, we can create environments with the help of VPCs. Now, so again, same thing. Why did we create these environments under VPCs? What is the reason? Yes, we can provide security side. So test VPC level and also dev VPC level, same time at instance level also as well. So this is second reason why we need VPCs. But so the major reason why we need VPCs is, let's talk about the third purpose. Okay, see, even at real time, if you get a requirement, can you create an instance? So how do you create an instance? So if you have VPC existing, you create instance in that VPC. And once you create instance in the VPC, and then you provide securities to the EC2 level, instance level. Okay, but if you have already VPC, if you want to create a VPC, so we don't have any VPCs. So I want to create new VPC. Then you create a VPC first, and then you deploy EC2 instance in it, and then you provide security set network level, also at instance level. So this is how you do it. Okay. So we don't create just like instances just like this, what we have done so far. No. So we have been creating instances, but within VPC. What is the VPC we have been selecting so far? Existing VPC. What is that? Default VPC. Right? Did you see that in the third step, whenever you create instance, so there is something called default VPC. So what is the default VPC? So default VPC allows any type of inbound rules. See, NACL, for example, let's say, now we have spoken about NACL, right? NACL is securities at network level. Security groups are securities at instance level. Remember, that is an important question. What's the difference between NACL versus security groups? NACL provides securities at network level, VPC level, and security groups provide securities at instance level. Okay. Then NACL also have two types of rules: inbound rule, outbound rule, same as security groups. So both have inbound, outbound rules, NACL and then security groups. Then, so that's the second difference. And the other major difference between NACL versus security groups. For example, I'm creating inbound rules for security groups. We all know what is inbound rules, right? Security groups, we have been creating inbound rules. So do you remember in the sixth step? So we create security groups, right? Whenever we create instance in the step 6. So we mentioned security groups. So what kind of security groups there are? Are they inbound or outbound? Inbound. But where are the outbound rules? Automatically means stateful, correct. Security groups are stateful, right? So you set up the inbound rules, and then those inbound rules will be applicable at outbound rule level. But whereas in NACL, Network Access Control List, you set up the security group set inbound as well as outbound. So what do we call it? Stateless. Right? That's the third difference. Remember, that is a major difference. Security groups are stateful and NACL is stateless. Remember that. We'll talk about that. Well, so that's the first reason, and this is the second reason. Let's talk about other important reason why we should have a VPC. Now here, the third difference or third important reason why we need VPC for deploying applications, application deployment purpose. Let me give you an example. So this is AWS VPC, AWS Public Cloud. On this AWS cloud, first I will be creating a VPC. That's a VPC. So within the VPC, then I create, we call it subnets. So what is a subnet? We'll talk about it. Now, VPC has subnets. I'm creating subnets. This is what we call a public subnet. So I'll explain. So public subnet, then we have a private subnet. Public and private subnet. And then within the subnets, we'll be creating our instances. So I'm creating instances over here. Instance 1 plus instance 2. I have two instances. Two instances. But now in these instances, I want to deploy some application. So there is some application, some email application, let's say. So I have an email application running on these two instances. How we do the deployments? We'll talk about that in the next weekend. But let's say I have some application running on these two instances. Okay. Well, now since we have application, so there are some application users. So this is an email application, right? That's an email application. Then we have application users. So just assume that you are a user and you're trying to access the application, which is an email application. Now, so what do you do as a user? For example, you are a user. Then what do? You have a browser. You go to a browser, open the browser, and you enter the URL of your application. Is it clear? Good. So in my browser, I enter the URL of my application. I'm a user. That's my URL. So once the URL is entered, and then you'll be able to access the application from these instances. Okay. And now, so these instances, so I have deployed them on public subnet. Why I have deployed these instances? Why instances are running on public subnet? So look at that application. This is a web application. That's email. It's a web application, right?
It needs connection to.
One second. So since it's a web application, so this application can be accessed globally. Internet users. So this application is open for all the users. So that's why I have deployed this application on these instances. Those instances are running on public subnet. So whatever the application you want the application to be accessed globally, so publicly, and then deploy the application on public subnets. So now is the importance clear? What is the public subnet? So whenever you want to have access of the application or instances of the instances deployed in public subnet, those instances or those applications can be accessed publicly or from anywhere. Okay, so that's what Let's please hang on. So I will be restarting my system online, please. Thank you. So yeah, sorry. Let's continue. So we are talking about where is it? Fine. So that's our AWS VPC. AWS, sorry, not VPC. That's an AWS cloud host. And then, so within that cloud, we create our VPCs. That's a VPC. And then, so within the VPCs, now we have the subnets. Then we create subnets. So we have two subnets. One is a public subnet. The other one is a private subnet. So in public subnet, we run the instances and then applications deployed. So here we have instances plus applications. And this application is an public application, web application. Right. So we have users. These users, they access the application and over the internet. So applications running on public VPC. Right. So our instances plus applications running on public subnet. Right. Well, but what is the purpose of private subnet then? So what type of instances we run it, and on those instances, what do we run them? Yeah. So let's talk about private subnet. Now, so I'm a user. I want to access my application inbox. So this is an email application, right? So this email application has some inbox. I want to see my inbox, or I want to see my outbox. I want to see my sent folders. I want to see the list of emails, right? Then, so there I would send a request that to the private subnet. Why private subnet? Within the private subnet, your instances, and in the instances, your applications. But what kind of instances they are? So these instances are database instances. So database instances will be running under private subnet. So why databases instances are running under private subnet? So that if any user, they want to access the database. For example, this is EC2 instance. Okay, this is EC2 instance, and this EC2 instance. So as a user, I want to do SSH, or else I want to access the database. So I want to log into the database. Can I do it? So just like, for example, yesterday we have seen. So we have created RDS database, right? Now that RDS database, so you want to log into the database. Yesterday I was able to do it, but usually not. Why? So I was able to do SSH, I was able to do log into the database yesterday using our MySQL Workbench, since that was a public database. Do you remember in the settings, well, when I was stating that I've set up that accessibility as public, but we don't do set up the databases as public. Instead, we set up that as an private. Whenever you set up the databases, you're private. Those databases cannot be accessed from publicly. If any user, even if you know the endpoint of my database, and you cannot log into my database, why? That database instance RDS, so will be running on private subnets. Then, so if the database instances are databases running on private subnet, then how database can be, for example, that user, he wants to access the database, he wants to access his inbox, but where are the inbox emails are? Inbox emails are running on databases. Then how you'll be able to process the data, or who is going to process the data? Or simply, how private subnet instances or private subnet databases, who can be, who can access them? Is the users can access them? No. Who can access that then? Public subnet. The private subnet can be accessed by the public subnet only. That means instances or applications running on public subnet, those applications can access my private subnet. Is it clear? Understand? So that means whenever user sends a request to access the inbox emails, then the request sent to the application servers, and those application servers will send a request to the database servers which are running on private subnet, and the request again sent it back to the public subnet, and from the public subnet user will be sent a response. Is it clear? Understand? Is it an you understand now how the application works? Always public accessible instances are deployed in public subnets. Those instances with databases, they're deployed on private subnet. So if you deploy these databases on public subnet, let's say, so is it secure? Why? Yes. So that database can be accessed by everyone. So that's why database is always running on private subnets. Okay. Is it clear? Well, now, so we are talking about public subnet and then private subnet. So is the purpose clear now? So what is the public subnet? What is the private subnet? Then, so how do we provide securities at subnet level? What is that? Network level security, subnet level security, network level security. So what do we call it? Which one? NACL. So what is NACL? Network access control list. So that network can be accessed only by particular set of group, that access list. So NACL is a security group which has been set up at network level or subnet level. So whereas security groups are set up at instance level, instance securities, and then NACL is network securities. Now, so in this NACL, in private subnet NACL, for this private subnet, I'm going to provide an inbound role. So NACL also have two types of roles, right? What are they? Inbound, outbound. Now I'm going to set up an inbound role for the NACL of private subnet, saying that, so security group, it can be accessed only by the, which one? Public subnet. So the inbound rule of, so private subnet is, what is the rule? It's only public subnet. That means, so databases or your private subnet process only or accepts only public subnet request, not the other type of request. Okay, understand? So then we can, as usual, if you want to provide security set, security group level inbound securities, as usual, we can set up security groups inbound securities. Okay, but so this is one type of VPC. Now in this VPC we have two subnets. What are they? Public, private subnet. Now VPCs can be set up. So apart from public and private subnet, our VPC can have only private subnet. That is also possible. Okay, let me show you. So when you go with just a second. So let me log into AWS. So go to VPCs and just search for VPC service. VPC is a service. VPCs. So it's kind of isolated cloud resources. So which is like, so if you want to set up your network which isolated, that means with some special securities, special access control, you can set it up. So that is what is isolated. I create a VPC using Launch Wizard VPC. So what is Launch Wizard VPC? Back to the picture. Now here you see we create a VPC. Within VPCs we have subnets. That means you can create VPCs subnet same time. That's possible. Or else first you create a VPC and once VPC is created, later you can create subnets in it. Now, but I want to create VPC subnets same time. Then you can use Launch VPC Wizard. Or I want to create VPCs first, then go to VPCs. Then you create a VPC. After VPC is created, then you want to create subnets. Then you can create subnets and add this subnet to the VPC. But Launch Wizard will help us to create VPCs subnets same time. Now, create a Launch Wizard. Now, there you can see that type of VPCs. So this is what we have. So look what we have been looking into so far. VPC with public and private subnet. Then you can have VPC with single public subnet. So that is also possible. We can have VPC with public and private subnet, but what is that? Hardware VPN access. So what is hardware VPN access? So we have seen a scenario, a VPC can have public and then private subnet. Okay, but look at these users. Who are these users? Who are these users? Public users, internet users. Do we create those users? No, we don't create the users. So, but if you want to create a user, let's say I have an VPC, that's a VPC, and this VPC has an private subnet, that's a private subnet, that's AWS, that's VPC, and then this is my private subnet. Private subnet. Okay. So I have an application running in this private subnet. This is my application. Now take a first example. So you are within an organization, you are an employee. If you are an employee, you have an employee portal. Then since you are an employee, so you have access to employee portal. You can log into the portal. You can check your employee information. Right? That's what you can do. Now, so that employee portal application can be accessed only by the employees. Right? But those employees, do we create them? That means as a user, let's say as an employee, do I create myself? No. So that users are created by in the backend. Your network teams, or else if you have HR teams, they create the users. They create the employee. So what users we call them? Those users, we call them VPN users. Okay, those are VPN users. VPN users are created by the particular set of hardware devices. We call them VPN hardware devices. Okay, so now users of the application, so is created by the VPN. We call them VPN users. VPN users. So these VPN users created by the VPN hardware devices. Okay. So in this kind of example, we have VPC only, VPC with private subnet only. But users are what kind of users? VPN users. So that's what is an example. VPC, sorry, the fourth one, VPC with what kind of, which is only a private cloud. The second example we have seen, VPC with public and private subnet, but the users are Who are the users? Outside. But in this example, we have VPC with private subnet only. So which is your, so what is that? VPN hardware devices. There. So if you go with the first example. So in this example, what is that? VPN with public subnet only. So, but how about the users? Are the VPN users? No, though they are not VPN users. So if you look at the first and second example, these users are not VPN users. These are web users. And if you look at the third and fourth example, the third example is VPC with public and private subnet, just like second example. But the difference between second and third is, what's the difference? VPN users only. And same as the fourth one. So VPN with private subnet only, but VPN users. So we can have these four type of scenarios when you create a VPC. Okay. Now again back to this example. So this is a user. So all these users are web users, and they access applications on public subnet. They access applications on public subnet. Okay. Now, so between the users and the public subnet or instances in the public subnet, so if you want to communicate, so there must be some securities again. What is the security? There are some gateways. What we call those gateways? We call them internet gateways. So what are the internet gateways? So here we talk about internet gateway. So this gateway is attached to the public subnet. So this is an kind of a security or a gateway. All the requests of the users must be going through internet gateway. We call them IGW internet gateway. This provides the security. This makes your subnet as an IGW internet gateway. If you want to make an subnet as a public subnet, and when the subnet is attached to an internet gateway, that subnet is called public subnet. So usually when you create a subnet, so there is no difference between public and private subnet. But how do you make sure, how do you differentiate the public and private subnets? If a subnet has internet gateway, and that subnet can be accessed globally across the internet, that is what we call internet gateway. Now, but so what internet gateways does? Internet gateways provides internet access to the subnets. If subnets does not have IGW internet gateways, that subnets cannot be accessed publicly. Okay. Then, how about private subnet? What kind of gateways they have? So private subnet has a gateway, and that gateway is called NAT gateway. That's a NAT gateway. So what is the purpose of NAT gateways? Now, this is, let's say I have an example. This is my instance. Now, this instance wants to have internet access. So what is the purpose? Now, so this is my database. Do you remember yesterday when I was setting up RDS? So I have set up some windows. So that means, what is that windows means? So scheduled windows. I want, let's say I'm installing MySQL Server 8.0.2, but I want to upgrade that MySQL. I have a new version. I want to upgrade that MySQL version. How do you upgrade it? We need internet connectivity. If your instances so wants to have internet access, right? Then so the internet access will be provided by the NAT gateways. From the NAT gateways, the request sent to the internet gateways and to the outside world, to the internet. From outside, I want to access something like this. Is it possible? No. Why? Because the request through NAT gateways works only one way. What is one way means? Instances can access internet. So through NAT gateways, the request will be internet request will be sent it out, but no request will be sent it back in. That's not possible. So in NAT gateways are one-way communication, not both-way communications. Whereas internet gateways are both-way communication. Moreover, those internet gateways accessible from anywhere. So that's the difference between internet gateways versus NAT gateways. This is the most important question, ICW and the NAT gateways. And the second question is, so NACL versus security group. These are the two most important questions. Almost like every interview, when you have questions on VPCs, the first question is NACL security groups, and then ICW versus NAT gateways, or how to differentiate. So what is a public subnet? What is a private subnet? If a subnet has internet gateway, that's a public subnet. If a subnet has a NAT gateway, that's a private subnet. Now, can you differentiate these two again? What is the purpose of this? Internet gateway gives access to the instances in public subnet, whereas NAT gateway also. So if instances want to have access to the internet, that happens to NAT gateways, but that internet communication goes only one way. Okay, so that's a very, very important question. And then, so let me show you this. So go back to the second example. So NAT gateway. So there you can see that we have NAT gateway. In between private and then public, so there is a NAT gateway. Then for public subnet, there is an internet gateway. The request goes to the public subnet through the outside. Okay, so this is how exactly the communication works. Are we clear? So if you understand this architecture thoroughly, then only we'll be able to implement your public and private subnets or VPCs. Even in terms of Terraform, so when you go to Terraform, we'll be implementing all these ones. So, but you're writing some Terraform scripts. At that time, you should be automatically understand how the architecture works of VPCs. Well, now this is what is your VPC wizard. But I'm not using a VPC wizard. I'm not using a VPC wizard. If you're not using a VPC wizard, then can we create still VPCs? Yes, we can still create VPCs. How? You have subnets, you create VPCs. You create VPCs. You create VPCs. And then I create subnets. I create my subnets, and then so all these subnets now I will be attaching to some VPCs. Okay, you see the VPCs for these subnets are running on so and so VPC. This is my VPC for Terraform VPC anyway. So and then scroll down. You create NAT gateways. I'm creating NAT gateways. That is my NAT gateway. So you have any NAT gateways? I don't think so. We have NAT gateways. Okay, that's okay. And you create a NAT gateway. When you create a NAT gateway, we attach that NAT gateway to the VPC subnet. I mean, you select the subnet. Okay. Then, so okay. Yeah, that's it. Yeah, there we have NACL securities. We create network access control list, and then the network access control list we attach to the subnets again, associated to so and so subnets. Okay, and then security groups are associated to the instances. These are all the security groups associated to the instances. You can see them. Security groups are associated to the instances, or else let me select some security group. I hope you know these ones, right? So these ones attached to the so and so VPCs. This is not loading. Let's refresh. We know these ones anyway. Just a second. Let me select something. So that's for so and so subnet, and that's a VPC. Obviously, you can go to the instance level. From there, also you can check that. So particular security group. Okay. Well, so even these ones, if you look at back, where are they? NACL, Network Access Control List. NACL also have, like I said, so both have inbound rules and then outbound rules. Okay. Now, but so for today, I'm going to show you how to create these VPCs using Wizard, VPC Wizard. So when you go to Terraform, so we'll be creating these VPCs instances using these all the options. That means without wizards. Okay. So for today, so since we are on AWS console, I will be creating VPCs with console. That means VPC wizard. When we go to Terraform, we'll be creating these VPCs and subnets, internet gateways, NACL, security groups. So each and everything manually. Manually means I create a VPC first, I create a subnet, then attach that VPC to the particular subnet to the instance VPCs, then deploy instances in the VPCs. We'll be doing them. So by following these steps. Okay. Now, so today let's start with VPC wizard. Okay. So go with launch VPC wizard. Now we can create only these two wizards, first one and then second one. The third one and the fourth one is not possible anyway. So the reason is we need VPN hardware devices. Okay. So if you are connected within a corporate network, if you have VPN devices, then this is possible. If you don't have VPN devices, you cannot do it. But let's go with first. So create a VPC with subnet only, which is public subnet only. Okay. Let's try with. So now there you can see these settings. The first settings are for so VPCs. This is for VPC setting. The first settings are for VPC, and the second setting is for public subnet. So we are creating VPC plus subnet same time. And now let's understand these settings. We have VPC first. So we call them CIDR block, CIDR block. So what is a CIDR block? So you see that this is what we call IP range. That's what we call IP range. So we are creating a VPC, but that VPC can accommodate how many instances or how many different IPs this VPC can create. For example, I have a VPC, right? Within that VPC, how many instances I can create? Can I create 10,000, 20,000, 30,000? So that is decided by the CIDR block. CIDR block we call it. CIDR. That block decides your number of instances, a number of different IPs your VPC can accommodate. Now in this example, it can accommodate about 65,000. But how do I know this? /16. So what is /16 represents? So we have some class ranges in the IP ranges or in the CIDR block. We have some classes. Class A, class B, and then class C. So let me explain. So go with CIDR block. We have 3 classes. Just try to Google it. So there are 3 class types. What is CIDR block? Basically, it is a kind of algorithm, you can say. So it's an algorithm which helps us to create a different IPs. It's a kind of algorithm. Then, so let me show you an example first. So go with class B, 4, 16, 65,000. Yeah. You see that? The same kind of IP range. So 10.0.0.0/16. What is 10.0.0? For example, I'm creating an instance in this VPC. What is my instance? Let's say instance 1. Once instance is created within that VPC, so instance will be given some IP address, right? What IP address? Some private IP address. So what is the IP address of it? The IP address will be 10.0.0.1 or 10.0.0.2. So let's say I'm creating instance 2. So if you create instance 2, what is the instance 2 IP address? 10.0.0.0. So on. You can create your VPC can create 65,000. So why 65,000? Because my class range is /16. /16 means, so it can create about, so 2 power 16. That's what you see here, 2 power 16. So where is that power? Whatever. So 2 power 16, which is so 65,000 plus. Okay. So the correct number is 65,536. Now, so that is what is class B range. Then if you go with 2 power 24, 2 power 8, yes, 2 power 24. So what is the representation is, let's say, which is 10.0.0.0/8, nothing but, so 2 power 24. So there you can create about 16 million IPs. You can accommodate about 16 million IPs. So what is 2 power 24? Why we call it 24? So basically this is like 32-bit. So 8 plus 24 is nothing but 32. Same as here, 16 plus 16 is 32. Okay. So if you mention /8, it can accommodate about 2 power 24, which is like 16 million IPs. But what if I have 10.0.0./24? How many we can create? 2 power 8. So this is your class C. There you can create about 256. Okay. So this is your CIDR blocks. Basically, it's divided into 3 categories. This is class B, and then we have class A, and then you have, so class C. So class A, B, C. These are the different IP, different types of, so CIDR blocks, class A, B, C. So what kind of class types does AWS supports? AWS does not support class A type. No. So AWS does not support this. AWS supports class B as well as class C range, class C type, class NB. So just look at here. So what is the class type? Class B. So it can accommodate about 65. So it has to be 65,536. But why it's showing us 65,531? The further other 5 IPs are reserved for the AWS purpose. Okay. Then if I change it to, let's say, /8. So it has to be between only this range, class A to class B range. If I go with, let's say, /24, yes, that's allowed. Now, what kind of CIDR block that is for? That is for VPC. Now, the same way, see, VPCs has subnets, right? VPCs, then we have subnets. Within the subnets, we have instances. Now, that means even subnets also have CIDR blocks. So VPCs, remember the architecture again. So we have VPCs, that's our VPC. Then we have subnet. Within the subnet, we have instances. Now, firstly, we are providing CIDR block for the VPC. Then we can also provide the CIDR blocks for the subnets. Okay, good. So what is the CIDR block for the VPC? Class C, which is /24. Now, what is the subnet CIDR block? What is subnet CIDR block is? Again, class C, which is /24. Now, can I make it as 16? No? What?
In the range of VPC and subnets are.
So subnets must be within the range of VPCs because subnets are part of VPCs, right? Since subnets are part of VPCs, so subnet range must not exceed the VPC range. So that has to be within the range. So if I go with 16, now that is allowed. Okay, are we clear? So your subnet CIDR block has to be within the range of VPCs. It cannot be outside of the range. Okay, good. So go with class B range and then VPC name. Now give a VPC. I'm creating a VPC with VPC scenario 1. So what is VPC scenario 1? VPC with public subnet only. That's scenario 1 we are creating. And then, so next is subnet CIDR block, and then you have availability zones. Now, select the availability zone. I have selected. So public subnet within has to be 1A or 1B or 1C. You can select the range. But some availability zone, I'm sorry. Now, based upon this availability zone, when I select my instance, okay, I'll talk about them, come back to that. So else first, let's see. I'm creating a VPC first, and my subnet availability zone is 1A. Okay, then give a name to this. So I would name it as VPC scenario 1. VPC scenario 1 public subnet. Okay, right. And then let's create it. So successfully created. Now you can launch instances within the subnet. Then okay. Now this is, we are under VPCs. Now VPC is created. You see that we are under VPCs, and this is our VPC. So that's our VPC. And so what is the CIDR block? That's the CIDR block. Okay, you can see the VPC information over here. And then that is your NACL network access control list. Go to network access control list. Select it. And these are the, so this NACL is associated with the subnet. You see the subnet, right? So what is subnet name? VPC scenario 1 public subnet, that is associated to the public subnet. Okay, well, now you can see the inbound rules. These are the inbound rules, all traffic. Now this is another difference. We have seen few differences between NACL versus security groups, right? So NACL is stateless, security groups are stateful. NACL is attached to the subnet and security groups attached to the instances. Then other important reason, this is also very important. Now you see, when you go to inbound rules, you edit the inbound rules of NACL. So what is that? Your inbound rules have some priorities. If I go with 100 as my inbound rule name, then that has highest priority. I want to create more rules. You can create more rules with some, add a new rule. I want to add a rule. So with, where is it? So add a rule, but it's not taking it. Okay, we already have gone for, this is the one. Yeah, this is the one. Rule number is like 101. And this has the second priority. And what type of rule that is? I would go with HTML rule. HTTP rule, I mean, HTML means HTTP rule. And then, so what do you want to allow? So I want to allow all users. Now you see that, allow. Then if I go with deny, what is that? No user can access my NACL or the subnets. This is denied. Now, this is the advantage we have with inbound rules. So in NACL or outbound rules, you can set allow deny rules with some priorities. But whereas in security groups, we can only set up the allow rules. You cannot block any users. Are we clear? So this is another advantage of NACL. NACL are set up with some set of rules with some priorities, and where we can set the allow rules and the deny rules, which is not possible for security groups. So these are the three important reasons you must mention when you talk about NACL versus security group. Okay. So you can go with deny, you can go with deny. Then you set them up, you save. Now you have deny rules also set up. Then, so now you can check the subnets associated with it. That's a subnet which is associated, which is a public subnet. So you see that what is happening. So we have created that VPC with a wizard. Right? How did we create that? With the help of VPC wizard. So we created VPC subnet, automatically even NACLs are created, and then that NACL is associated to the subnet. But if you don't have a wizard, then you create a VPC, you create a subnet, you create NACL, then you associate that NACL to the subnet. Is it clear? Now you understand the importance of wizard now? That's a wizard. So in the past, so this wizards was not available. So they have introduced just about 3-4 years ago, but it is not available in the past. Now the question is how the subnets and VPCs are associated. Understand the question? So we have subnets, VPCs, subnets and the NACL are associated, right? How they're associated. So for example, let's say I'm creating a subnet. Okay, now manually, I'm not using a wizard. I'm creating a subnet. Okay, it's created. Also, I will be creating an NACL. So I will be creating a NACL. So both are created. NACL created, also subnet created. But how they're associated? Sorry? Not because of CIDR blocks. So you have, 1 second. There it is, route tables. Okay. So what route table does? Route table is for associating NACL with subnets. So scroll down. So see that, so these ones, like I said, I will be creating them even through Terraform, but in the future, not now. So, sorry. So which one? So what is the one we have created? So it is scenario 1. This is the one. When is it created? Just now. The date and time won't be there, I guess. That's okay. I think this is the one. Okay. So there it is, VPC, and then also subnets. Sorry, not. You can go to the VPCs. I'm sorry. So go to the summary. Then you have VPC scenario 1, and that VPC has your subnet. Now remember these 3 points. Okay. Remember these 3. So the first point is you create VPCs. Second point is you create subnets, and then you create NACL. Sorry, you create NACL, and then at the end you create route tables. So what is the purpose of route tables? Route tables are used to associate. So associate with subnet, and then NACL. So please concentrate. So we create VPCs and we create subnets, and then we create route tables. Then route tables are used to associate with, so subnets with NACL. So if you don't want to create all of them, so manually you can create VPC wizard. Okay. So now we have created public subnet, also a public subnet, right? Public VPC and also a public subnet. Now just do one thing. So my laptop is again shut down. Just okay. Now what you can do. So I will be showing this example, of course, in the next coming week. That's not a problem. But I have created that, and even I have shown you that are they associated each other? Yes, they are associated each other. Okay. Just try that from your side. If you are interested, what you can do, just go with create a VPC, create a subnet, and create a NACL and route table associated that with your particular subnet or VPC. Try that manually. But so for me, I mean myself, in my example, I will be showing only these things manually, but that's through Terraform, not here. I've given all the picture, how it works, how they're associated. But so when you go to Terraform, I will be creating them, but with the help of only scripts. But here we have seen how to create them using wizards. Okay. Now, so we have second scenario. I will be creating an VPC with public and private subnet. So, and then we'll be creating NACL, we'll be creating security groups, and we'll see that in the next week. Now, but today what you're going to try, create that VPC wizard with public subnet only. Try that first, that's your first scenario. And once it is created, then you create an instance. We know how to create instances. Create an instance, launch instance. And in the third step, do you remember the third step? So what is the third step regarding? Select the VPC. Select the VPC plus once you select the VPC, it is going to display the subnets associated with that VPC. That's only one thing you do, and then launch instance. Are we clear? Once instance is launched, check that that instance is particular VPC and subnet associated to that. Okay, you know how to do it. When you create instance, select the instance, then at the bottom you have networking option for the instance, right? Select it and then check that whether subnet is created. And that's one thing you do. And also check that, so we have created VPC and then subnet in which availability zone? 1A zone. And your instance zone also has to be 1A zone. Are we clear? So why instance will be launched under 1A zone? Why? Yes, because since our subnet was also created under 1A zone, your instance also will be created under 1A zone. Clear? So try that. So this is what your observation has to be at the end. You create the VPC wizard. After that, so you create an instance. An instance has to be launched within the VPC and then subnet. Then observe that whether instance is created under same availability zone as your subnet. And also check the IP range. So what is IP range we have provided? 10.0.0.0, right? And your instance private IP also has to be within the range of subnet or VPC. Okay, so check this out. Yeah, so these are your observations, and try these things from your side and understand the whole concept. So what is a public subnet? What is a private subnet? What is NAT gateways? What is internet gateway? Now, so you will be given an scenario basis question in interviews. So for example, I want to launch an instance. Can you give me the steps how to launch instance? Or can you give me the starting to end steps, how the VPCs are created, how to create subnets, and what kind of gateways you attach to them? And then I have an application. My application has public and private, sorry, my application has an application server, also database server. Now tell me, how do you create these instances? I have application A. For that application, I have a public subnet. Sorry, my application has a application server, also database server. So this is my scenario. Tell me how you're going to deploy these applications in VPCs. What kind of VPCs you're going to create? Yes. So since in this example we have application servers, also database servers, I will be creating a VPC with two subnets, public and private subnet. On the public subnet, so I will be deploying application servers, and private subnet I will be deploying database servers. And for the public subnets, I provide NACL, internet gateways, and then allow from everywhere. But whereas for the private subnet, I will allow the securities only from the particular private subnet. But that scenario we have not taken that yet, so we'll take this scenario in the next session. Okay, we have created only public but not the private. Okay, we'll be doing it practically in next session. Okay, and also, so we create instances only within VPCs. Never create instances in default VPCs. We create instances in our own VPCs, so that we have the full control of the networks and their securities. Okay, so try these ones, and let me give you a question. You try this answer from your side. If you're not able to do it, so let me know. I can give you a solution in the next session. So I have an instance in private subnet. Okay, so since it's a private subnet, can I do, so let's say I have private instance. Sorry, I have a private subnet. I have instances in the private subnet. I want to do SSH onto the instance in the private subnet. How do you do that? Is the question clear? Simple question. I have a private subnet instance. I want to do SSH onto the instance. How do you do that? You change the security groups. That's a private, right? Why do you want to change the security groups of private instances? If your private instances are changed to access everywhere, then where is the security? Understand? Are you going to change the NACL? If you change the NACL again, that has to be SSH, right? SSH from everywhere, SSH from particular IP address. But these are private instances. I don't want to provide any SSH rule in the private instances or private subnets. But how are you going to do SSH? Which one? Sorry? NAT instance? No. See, who can access the private instances? Only public. Yeah. Okay, you know the answer now. Tell me. Create a public subnet. Okay. Then. Correct. Yes. Correct. You create a public subnet, and that public subnet create an instance, and to that instance you can do SSH, and from there you do the SSH to the private instance. You remember the SSH concepts now? Now do you understand the importance of why did we do SSH? So I have shown you already. I have done SSH from one instance to another instance. So for this purpose, okay, try that. So what we call this instance? We call them, the public instance is what we call Bastion instance. Bastion, BASTION, Bastion instance. Okay, so try this concept. If you understand it, if you're able to do it, do it. Otherwise, don't worry. I will be showing that in the next session. So this is an important question. This is the third important question in the VPCs. How do you do SSH onto the private subnet instances? So already I have given a couple of questions. NACL versus security groups, and plus what else? What's the second question? What is that? NAT gateways versus internet gateways, and this is the third question. Okay, remember these questions. Right? Yeah. Any questions from your side? So you got the idea now. So you got the importance of the VPCs. Okay. And those who have not created RDS, okay, or if you want to create one more RDS instance, so what you can do, you can create that under your own VPCs. You create a VPC and create a subnet, then you create RDS. That RDS you select your public subnet or private subnet. Try that. Okay. So the scenarios document is already in the Google Drive, and I don't think so you'll be able to practice all the scenarios. So practice the scenarios which you understand, and rest of the scenarios are related to private subnets. If you can't understand them, just leave them. You can do hands-on in the next session. Okay, clear? Any questions? Yeah. After selecting? Yes. Yes. You can do it. Okay. So you can change the VPCs even after instance is created. That is possible. You can modify them. Okay. So, but that's all different. We follow different steps. Okay. You try that through the console first. So we have this AWS console, right? You try that through the console. You edit the VPC, edit the subnet, or else you can go with edit the instance. Try to do it. If you're not able to do it through the console, that is possible through, again, we have a tool, Terraform tool. Sorry, already? DB, yeah.
They are associated with
Yeah, you can modify the settings. So if you have, yesterday I have created an RDS, right? For that we have created an publicly accessible, which is under default subnet. Okay, now you can change that. When you go to that modify and change the VPC, you can change the VPC. You can do it. That's possible. Okay, so VPC subnets can be altered, can be changed, not a problem. Yeah. Any more questions? No. Okay. Thank you. I'll see you tomorrow. Thank you.